Today, we will be talking about limits to infinity. And limits are a very important part in math, where they describe what value something is approaching as you get closer and closer to a certain point. Today, we will be tackling limits as they tend to infinity. Whenever we're solving limits to infinity, we care about one thing. We care about x with the highest power. And we care about that in the numerator and in the denominator. That's why we have n, which is denoted for numerator, and d for denominator. We have three cases where the highest power in the numerator is greater than the highest power in the denominator. The highest power in the numerator is equal to the highest power in the denominator, and the highest power in the numerator is less than the highest power in the denominator. I put an example for each one so that we can understand more. Now, let's start with the first one. Whenever the power in the numerator is greater than the highest power in the denominator, the answer will always be positive or negative infinity. So, here we have limit as x tends to infinity, and we'll need to check what is the highest power of x in the numerator. The highest power of x in the numerator is x to the power of 4, where we'll take 4x to the power of 4. We take it with the coefficient of it. And the highest power in the denominator is x. Now, if you want to simplify it, we have limit as x tends to infinity of 4x cubed. X to the 4 over x will give us 4x cubed. And now if we replace x by infinity, we'll have 4 times infinity cubed, which means 4 multiplied by infinity. So our final answer will be infinity. That's the first part. Now, what if the numerator, the highest power of the numerator, was equal to the highest power of the denominator, like the second case? In that case, we'll first check what is the highest power in the numerator. The highest power is x cubed, or 3x to the power of 3. And the highest power in the denominator is also x cubed. So we'll take x cubed with its coefficient. So 3x3 over 4x power 3. And now we can simplify that by cancelling out the x cubes. So we'll be left with 3 over 4. Whenever numerator is equal to denominator, the final answer will be the coefficients of the highest powers, of the highest x powers. Of course, we'll do more examples incoming. Now, whenever we have the highest power in the denominator less than the highest power. Now, whenever we have the highest power in the numerator less than the highest power in the denominator, like part 3. In part 3, the highest power in the numerator is 3x squared, and the highest power in the denominator is 4x power 5. So, we write limit as x tends to infinity, and of course we always keep writing limit as x tends to infinity until we replace the final value. Limit as x tends to infinity of 3x squared over 4x power 5. And now here we can simplify it further by cancelling x's. So x power 2 over x power 5 will give us x power 3 in the denominator. Now, if we replace it, we have 3 over 4 times infinity cubed, which is equal to 3 over 4 times infinity. 4 times infinity is of course infinity. And now we have 3 over infinity. Whenever we have any constant over infinity, the answer will always be 0, no matter what. So, as a conclusion, we can say that whenever the numerator is less than the denominator, the answer will always be 0. Whenever the numerator is greater than the denominator, our answer will be positive or negative infinity. And whenever the numerator is equal to the denominator, it will be the coefficient of the numerator, highest power, and coefficient of the denominator with the highest power. Let's do some more examples. Let's say we had limit as x tends to infinity Let's do this example. Here, we can either do it the way we did above, or we can factor up. Here, we can either do it the way we did it above, or we can do it in another way that I'll show you in a bit. If we do the way that we did above, we just care about the highest x power. So here in that case, the highest power in the numerator is 3x power 5. And the highest power in the denominator is 4x power 5. So we'll have 3x power 5 over 4x power 5. And now we can cancel out x power 5 and x power 5. So our final answer will be 3 over 4. This is the quick way that I taught you. Another way is here, where you factor out the highest x power from the numerator and the highest x power from the denominator. So, in that case, as we said, we have the highest x power up as x power 5. So we'll take it as a common factor. Now, removing x power 5 from 3x power 5 will be left with 3. And removing x power 5 from the 2x will be left with 2x over x power 5. And removing x power 5 from the negative 1, we'll have negative 1 over x power 5. And we do the same thing in the denominator. We take x power 5 up, and we do the same thing in the denominator. We take x power 5 as a common factor. Removing x power 5 from the 4x power 5 will be left with 4 minus 2 over x power 5. Now, as I mentioned before, whenever the power of the numerator is less than the power of the denominator, power of numerator is less than the power of the denominator, the answer will be 0. So here, we can see in the 2x over x power 5, the numerator is less than the denominator. So we can take this as 0. And negative 1 over x5 will also go to 0 because numerator is less than denominator. The same thing goes for the negative 2 over x5. Now, we can also simplify the x power 5s that we took as a common factor. So they'll cancel out. Now what will we be left with? 3 over 4, which gives us the same answer that we had before. Let's do another example. Okay, doing this example, if we do it the way that we did before, we said we take the x with the highest power. So the highest power in the numerator is 3x squared, and the highest power in the denominator is 4x cubed. So we'll have 3x squared over 4x cubed. If we simplify that, x squared over x cubed will give us x in the denominator. So we'll have 3 over 4x. Replacing now infinity instead of x, we'll have 3 over 4 times infinity, which is 3 over infinity, and any number over infinity will give us 0. Let's do it now by factorizing like we did before. If you want to factorize, we need to take the highest power in the numerator and denominator. So let me explain it more. As we said in the numerator, we have the highest power to be x squared. In the denominator, we have the highest power to be x cubed. In that case, we'll take x cubed as the common numerator and denominator. So we will ignore x squared. We won't take it into consideration. So maybe if we solve, you'll understand it more. limit as x tends to infinity of, we take x cubed out. So we'll have 3x squared over x cubed plus 5 over x cubed. And we do the same thing for the denominator. We take x cubed as a common factor. We'll be left with 4 minus 1 over x cubed. And now, as we mentioned before, x squared over x cubed will go to 0. 5 over x cubed will go to 0. Negative 1 over x cubed will go to 0. And x cubed and x cubed will cancel out. So we'll be left with limit as x tends to infinity of 0 over 4. And 0 over any number is 0.